Hey everyone, welcome. My name is Randy. If you don't know who I am, I'm not Randy McMillan, although I should use it as my pseudonym, maybe Randy McMillan too. And I named this talk Miniscript for Devs because Miniscript isn't really something I feel that has been too accessible in terms of understanding for the regular average Bitcoin dev, and I wanted to make it simple. So really, it should be Miniscript for plebs. But this is good enough, so, you know. Also, I am a hobbyist, a Miniscripter. I do not work on it full time. Letting people know. I work full time for Blockstream on Greenlight. Miniscript is a hobby of mine. Make it very clear. So we can go over things that I'll be talking about here, so you guys aren't, blindsided and can leave if it doesn't interest you. The first thing is what Miniscript is, just basic definitions, which Rob kind of covered a lot of, and I skip over, so that's great, because I was anticipating. The second thing is why Miniscript is important, or why I think it's important. The third thing is right here, how Miniscript works at a very basic level. So I don't actually go into Miniscript, the policy language. I do go into bare Miniscript, which maybe you're interested, maybe you're not, but I think it's more interesting. And I will go over more of why I didn't go over policy a little bit later. But see, like this is not what I will be doing because, again, I am a pleb and a hobbyist, so really I am like you all, and just another minion. So just to set expectations. Anyway, the main question is, what is Miniscript? Again, all this is at a basic level, or I could get a little bit into it. And you don't have to know Miniscript right now as I go into it. But the basic thing is, hopefully, you understand the basics of a Bitcoin transaction and that you can program kind of your UTXOs. But Miniscript is a programming language used to program spending conditions for unspent transaction outputs, so AKA UTXOs. And the next question I want to ask is, why is Miniscript important? Why are we all here? Why do we talk about it? And there's a blurb here, which so the main innovation to me is I think Miniscript is important because it makes it easier to create spending policies with Bitcoin script. It does this by introducing a human-readable syntax and using a type system that makes any Miniscript program or expression statically analyzable, which I'll get more into as well. It allows us to make assertions about our locking scripts, which helps us avoid certain pitfalls that malicious actors can use to force unexpected outcomes. Kind of like how Rob was saying, when, well, that was a bug in Miniscript, but when you make scripts, you have to make it such that it's secure and that it can't be messed with, and that, I guess, the bug was an example of a script that wasn't safe, and Miniscript is supposed to prevent that from happening. Next slide is, so typing. I think types are a huge innovation of Miniscript. Type constraints equals safety. So I was a TA for an introductory programming class in college, and most of the beginner programmers took type programming languages kind of for granted and saw untyped languages as an innovation, which is funny because in reality it's the opposite, right? We started off with regular bytes and byte manipulation, and types came as an improvement to that. It's something that we made. We created structure from nothing. So programming languages like C++ or Rust, they add structure to the chaos that is the untyped byte manipulation done in assembly. Types classify data to give us safety from unexpected results. And just to kind of go into certain typing things, a world without types lets us write code expressions like hello plus undefined plus null. If any of you have used JavaScript, you'll know that this doesn't result in an error. It'll just result in one long string with all these terms inside of it. And again, this is unexpected behavior that we don't like. So Miniscript has a basic concept of types that you'll see with expressions that disallow certain things. So similarly, the world of Bitcoin script will allow us to make our witness script like a check sig verify, for example, and not get an error. So to satisfy a script, you need a single one or non-zero value at the end for it to be satisfied and actually pass validation. So humans are not perfect, therefore we need tools to help point out our mistakes. And Miniscript is just one other tool that we can use. So right rehash on why Miniscript is important, because I just want to make sure that you get the main ideas here, not super technical. It's more human readable than script. It's statically analyzable, and it's a result of this new type system that was created. So some background on script for those who may not know what script is. Again, Miniscript is something that compiles to script the policy language, and whether the base language does. Compilation is a tricky word, but I say it does. So script is a stack-based programming language. Scripts are a sequence of data pushes and operations to be formed on the data that was pushed. And it's not the easiest to reason about. I kind of show an easy example of what script is on the next slide. This is courtesy of BitScript. It's a very basic script, so even if you're not experienced in script, you can still understand what it's doing. It's pushing a 2, it's pushing a 1, and then it's adding it. And you might be like, yeah, this is easy, right? All it's going to do is add 3, and you see this final example of this value 3. And it's like, okay, well, now do this one, right? How easy is it to reason about this long script? And you probably can after looking at it for a little bit, but it takes a while, and it's a stack-based language. It's very hard to reason about semantically when seen like this in this form. And the takeaway from that is that Bitcoin script is hard. Bitcoin script is as hard as any low-level language would be. Well, not as hard, but primitives may be easy to comprehend, but understanding the composition of all these primitives is the difficult part. So a story of constraints in Bitcoin script. Maybe this is kind of a mangled story. So again, type constraints kind of resulted in safety, but in general, certain things have resulted in safety for script. So if you ever looked at the original Bitcoin source code, you will see that there's, it contained implementations for a variety of opcodes, as seen in Rusty's talk about the Great Script Restoration Project. There were a lot of them were disabled, and he was talking about bringing some of them back. And there was some idea of standardness that applied, where only pay to public key and pay to public key hash scripts were allowed when creating or signing transactions. And again, if you ever looked at the original source code, you'd see this. And I have these, are they showing up? I have QR codes on these. I think they're getting truncated maybe, or just not showing up. But you could scan, and this is supposed to lead to the first commit that you could actually find on Bitcoin on GitHub. But yeah, this is a function called solver, and we had these templates. And you could have things like, there's a checksig template, and there's one for doing the public key hash. And these templates were made for safety, both for like Bitcoin nodes that validate these scripts, and for the people who are using these. And another kind of interesting development about, again, constraining Bitcoin script and talking about its evolution is P to SH, or pay to script hash. On the Bitcoin Talk forum, there was like seemingly a long discussion about having this new address type that would unlock you to these more relaxive scripts. And they were trying to figure out how to transition to this without opening up the floodgates and making sure people knew that they were using, or there could be a possibility of sending to scripts that were arbitrary. And I got this quote from Bitcoin Talk, and this is another motivation for being able to write more robust scripts than just pay to public key and pay to public key hash. And Gavin Andreessen kind of wrote this. I want more secure wallets. There's unanimous agreement among developers that the easiest, fastest way to get there is with multi-signature transactions. Bitcoins that require approval from more than one person or device to spend. Which right now, if you use Bitcoin, that's trivial. And it's funny because we're having similar debates today with covenants, right? Opcat, CTV. But you essentially have people who sound a lot like him saying, hey, here, sorry, I forgot to move to the next slide here. I have two slides going on. That's the quote here. And yeah, we have the same discussions today, right, about how we can enable new things on Bitcoin that can maybe make our coins more secure, like OpVault, or using OpCat for vault constructions, and all these other cool covenant opcodes that might enable more than we think will be enabled here. So wallet descriptors were also another push in this space. It was defined separately from Miniscript. It has its own BIP, and it was a way that you could have more scripts in a way. So as you see here, it might be kind of tiny on this projector screen, but there's PK, PKH, script hash, basically a lot of ways to make new scripts with these new address types. Sorted multi, combo, and this is it's predating the implementation of Miniscript in Bitcoin Core in terms of usage, but it's integrated into Miniscript, so you can use these wallet descriptors. In fact, it's kind of standard to be using this with Miniscript. And some cool things about wallet descriptors are they include derivation paths for keys. The address type is specified, and descriptors can indicate one of the keys is used in like a multisig, for example. And taproot multisig was a big thing that descriptors were supposed to enable if you wanted to construct a multisig address with Bitcoin Core. And the big takeaway, I guess, for that small section is that people want advanced scripts for multiple different reasons, but mainly to keep Bitcoin running well, whether it's for scaling, to keep their coins safe, but people want advanced scripts. And Miniscript is a way to give them a little bit more choice in what they're able to do with scripts. I think I skipped a couple here. Yeah, people want advanced scripts. So there's problems with programming in script. And I don't go over all the problems, but I can go over some of them. And one of the problems is it's hard to determine whether a script is satisfiable. If you just had a regular script with opcodes flowing around, just like I showed you before, where I said try and reason about that. When a script is satisfiable, again, these are kind of my definitions. It's not hard coded in if you ever look at the official Miniscript page specification, the word satisfiable is never defined. It's just kind of used, but this is my definition. And it's satisfiable if there's a witness for that expression that will not fail and will optionally cause the script to push a non-zero value onto the stack. And when a script is dissatisfiable, there's a witness for that expression that results in a 0 on top of the stack post-execution. So historically, it's been a challenge to declare whether a script is satisfiable or not in a fully automated way. And again, the Miniscript compiler can actually give you this type of information. And this has led to some Bitcoin becoming unspendable. If you have a script with a whole bunch of opcodes and you have no idea actually how to satisfy it, and there's no tools to tell you if it's actually satisfiable. And I have a little example here of, again, early Bitcoin talk post, or not super early, it's 2018. But there was a block mined by F2 pool, and in their script, they had some bytes that weren't actually opcodes. It spelled out the word script. And this was probably because of some bug in the software where they were trying to embed the value of a variable script, and ended up actually putting the bytes of script, and it's yeah, pretty funny. But there's not really a way to 2012 was when this actually posted. This is referenced 2018. And yeah, it just kind of goes to show that people don't really know what they're doing most of the time when they use raw script. And it kind of locked up these coins because this is unspendable, not satisfiable. So another problem is it is hard to identify satisfaction malleability. So and I'll go into this. Pre-SegWit script malleability resulted in the transaction ID being malleable. And the locking script is called the script public key in a transaction. When you spend it, it's in the script sig. And having things in a script sig be used for transaction ID calculation ended up causing problems, which is one of the motivations for SegWit. So today it can result in griefing a counterparty on off-chain protocols. This is kind of a trivial example. But let's say my off-chain protocol requires the script op sub, op for, op equal verify, and blah, blah, check sig. If I were to broadcast this satisfaction for this transaction, there's actually multiple different satisfactions because a lot of duos of numbers can result in the value of 4 when one is subtracted from the other. Yeah, I haven't actually put this script in and tried it in a transaction, but I think it would work if I tried to mess with these numbers, and it's kind of clearly looking malleable. So if I was a malicious counterparty, I would pick the biggest numbers I could to drive down the fee rate with the size of these numbers. Taproot has something called minimal if, which basically allows or kind of forces you to put a minimal representation of numbers in script. But before that, it didn't really have these rules that it was constrained by. But either way, having like big numbers, arbitrary to numbers, could still run up pretty big. And here we go here. So this, again, isn't a huge problem today, but this is part of this transaction ID malleability thing before SegWit, and helped inspire what SegWit was. So basically what some people would do is they'd ask for money from some exchange, and then they'd take the script sig, and then they'd malleate the script sig a little bit, get a new transaction and transaction ID, broadcast that in such a way that maybe they were able to get to more of the nodes faster and get accepted into a block, and then tell the exchange, hey, I never got my funds. And then they'd talk to support. Support would be like, yeah, that transaction ID wasn't in the blockchain. Let's just send it to you again. Very bad problem. But SegWit was great because it fixed things. So how does Miniscript solve these problems? Again, that was a non-exhaustive list. I just don't want to go over all the hard things with script. So yeah, static analysis. Type properties and static analysis is what I'd say are Miniscript's big things going for it. So before I get ahead of myself, I do want to lightly touch on how Miniscript works. I don't want to get anyone too lost in the weeds for anything. And Rob already gave a great introduction to this. So to define some basic terms, I kind of use this phrase Miniscript primitives. And I say they're referred to as fragments and wrappers, these two classifications of these Miniscript primitives. And each Miniscript primitive has a type and a set of properties. So primitives can have arguments / subexpressions, and the arguments must abide by type restrictions depending on the fragment that you're using. And the properties of certain primitives are determined by the properties of the subexpressions passed into them as arguments. And we can look at that as well. So some Miniscript types, the types that are defined in that spec page are B, V, K, W, and they classify the behavior of Miniscript primitives with respect to where it takes from the execution stack as input, if it takes at all, and what it places on the stack as output on satisfaction and dissatisfaction. So the list of types, again, are base, verify, key, and wrapped, as you might have seen in Rob's talk if you were here. In most of the existing compiler implementations, these types are referred to using their first letter. So you'll see B, V, K, W. And I can go over what each of these types do. I think I'm OK for time, maybe. But base type optionally takes an input from the top of the stack. And on satisfaction, it leaves a non-zero on the stack. And on dissatisfaction, it leaves a 0 on the stack. So some very basic rules dictating this base type. And an example of a base type is just using PKA, which takes a signature for the public key A of a transaction. And if a valid witness is provided containing the signatures for the public key A, checksig will place a 1 on the stack. If the signature is incorrect, it'll place a 0. Again, very basic examples with these basic scripts. So the type verify, it optionally takes an input from the top of the stack. On satisfaction, it leaves nothing on the stack. And it's impossible to dissatisfy. It just fails when it's not satisfied. So an example of this is auth verify. If you actually couldn't put this into, did I? Nope. All right. Again, sorry. It's 2 different slides. So this example of Miniscript is, if you try to put it into Rust Bitcoin, it wouldn't actually be allowed through unless you're partially insane. They have these ideas of like sanity checks, which is part of the static analysis that I was referring to before. But anyway, if you put 1 auth verify, no input is taken here, and on satisfaction, nothing happens. If you had 0 auth verify, this would result in the interpreter aborting execution of the script. again, because whatever's on the stack needs to be non-zero to be valid for auth verify. And then you have something called wrapped. Wrap takes an input from one beneath the top of the stack, never the top, for reasons. And on satisfaction, it leaves a non-zero or one beneath the top of the stack, or non-zero value on top of the stack. And on dissatisfaction, it leaves a 0, one beneath the top of the stack or on the top of the stack. And an example is two alt stack. There's an alt stack in the execution environment of script, and this puts something to the alt stack. It calls this check sig with the public key B, and then you get the value back from the alt stack. So pretty much the evaluation of that check sig goes below what was put on the alt stack at the beginning. So again, it outputted something one below the top of the execution stack. And finally, we have key. And okay, yeah, that was wrapped. And then key. This is key. And key optionally takes an input from the top of the stack, and on satisfaction, it leaves a key on the stack, and on dissatisfaction, it leaves a 0 on the stack. And an example of this is PKK, and all it really does is put the key onto the stack. So no input is taken here, and the 0 can always be provided in the witness for dissatisfaction. It has the satisfaction of a signature, which is, kind of weird, because this is a key primitive. It just puts a key on there. But I guess it makes sense when you compose it with a wrapper, like the C wrapper, for example, forces a check sig on this key. So a satisfaction there would be a signature. So Miniscript properties. I don't really go into all the properties, but I can give a high-level explanation. Properties allow us to classify different primitives and compositions of primitives with things we may care about. So properties cover classifications relating to the types of arguments allowed for a Miniscript expression in the witness, having like non-zero number of arguments or 0 number of arguments, and to whether a Miniscript expression is malleable or not. Again, kind of rehashing from what Rob said in his talk. So here are some examples. SHA-256, this fragment is non-malleable because there's no other witness that can satisfy this expression except the preimage. At least with the assumption that we can't find collisions easily in SHA-256. So the properties are inherited from parent fragments or wrappers. So some questions we could ask is ANV, is this malleable? And this has like a verify in the public key A, and then if you're able to satisfy the signature, then you're okay. And this is just kind of like one afterwards. And this kind of requires SHA-256. So again, you need a specific preimage to satisfy this. So yeah, non-malleable as long as you have to go through the SHA-256 and provide that preimage. Well, unless the second condition allows different things to be put in there. So like multi 1A, I guess, had an example here. So yeah, simple at-home exercises you could do. So here's a full list of the fragments and wrappers. And here, it's probably hard to see on the projector, but the types, you see these are like one-letter types. Here, again, base, verify, key, wrapped. And these letters represent those types. And then you have these properties, which are also represented by letters. And this isn't the most readable, in my opinion, but this is part of the spec page. And you could actually see what properties each fragment has, depending on its child. And its children is kind of like denominated by these subscripts of ZX, ZY. Again, not super readable, the spec, but maybe with some context before going into it, it might be more comprehensible. So using Miniscript. There's not many implementations. There's a lot of bindings, but there's not like core implementations I see made. There's the one in Bitcoin Core. Miniscript is supported in Bitcoin Core. There's one in Rust Miniscript, which Sanket and Andrew work on. And there's Python BIP380, and Miniscript Go, which I think is made by a guy from BitScript. Sorry, that's just an alarm to let me know. Might be close to the time. But these are all implementations. By the way, you could scan any of these QR codes, and they will bring you to these different repos. The only one that, or the two that I would trust is, well, it's not that I don't trust either one. I don't think all of them are made for production use. So the first two, from Bitcoin Core, obviously it should be good, and Rust Miniscript is also what a lot of implementations are built off of. So there's 3 big complaints I guess I have of the tooling as it is today, which is I'd like better error messages. I'd like it to be a little bit more extensible, or easy to extend, maybe is the better word. And I want it to be lightweight. And I wanted to compare and show you some of the implementations that we have. I'm kind of going to skip Bitcoin Core in comparing things for obvious reasons. If you've never seen the implementation, it's a little bit hard to comprehend. They use some operator overloading to do their type checks, and they use a lot of letters, and it looks kind of cryptic. So I'm not even really going to use this when comparing implementations. But when I talk about better error messages, I kind of want it to be as clear as possible for someone who's just learning Miniscript to see what's wrong with the Miniscript policy or not, expression that they've written. So if you look at the one on the top left, that's Rust Miniscript. It gives you what's wrong. For example, if you had an argument that was of incorrect type, it would say, hey, we actually were accepting this type instead of that type. But they use letters, and I kind of want to move away from letters and use the whole words like base, wrapped, verify, and I think that might kind of make it hard if you're new to programming in Miniscript. The BIP 380 implementation, it just kind of gives an error. So it raises an error. You're looking for a property within some array in Python. And then in Go, again, it kind of uses these letters, which it's fine to use letters. I just think it would be easier for a new or average dev to go and understand at least the whole word or maybe some description of a type. Extensibility, as again Rob mentioned, Jeremy Rubin, he added inscription support to Rust Miniscript in his own fork, and he had to touch a lot of different files. And I was wondering if there's a way that he doesn't have to touch as much, and it doesn't have to cover such a wide range of the code base. And again, that's another desire I'd want from Miniscript library. So regardless of whether you think this change should be made, inscriptions, whatever, the number of files needed to change is a little bit superfluous in my own opinion. So so lightweight, again, there's these different dependencies. The BIP 380 isn't too bad. Rust Miniscript kind of takes in the whole Bitcoin, Rust Bitcoin, and Miniscript Go has a couple others. Again, not too crazy, but all these have some dependencies. I think the build times of Rust Miniscript is a bit long. So again, these are just things, if you're a developer, that you should be aware of. And maybe if you like contributing to open source libraries, go ahead and look at them and try and contribute. And so using Rust Miniscript, this is a simple example. It actually isn't too hard to use once you start using it. This is a very simple example where I put PK, which is a check sig, and it accepts a key, and it'll make that script for you. So yeah, this it would be nice to have examples, I guess, on the README, or maybe there's a directory. But so here I was using Elements Miniscript, by the way, not actual Rust Miniscript, because I was trying to do some things with covenants. And if you use covenants, you don't get all of the security guarantees you get with Miniscript. The properties kind of get janked up a little bit, which Songkit will probably go on in his talk. So I also was kind of messing around again as my hobbyist Miniscripter. I wanted to make my own library, Miniscript.js. It is nowhere near production use, very experimental, probably not very good for much of anything, except quick builds and quick testing of your Miniscript expressions. It does basic type and property checks. So better error messages, this is kind of what I meant. In my own hobby implementation, the better error messages is I put "and-v" could not be constructed because its first argument was not of type verify. Please make sure the first argument is an expression that leaves nothing on the stack. I think that's more descriptive than the first one. I'm still playing around with it, trying to figure out ways that I can make mine very developer friendly. Again, I'm a developer, a pleb, the minion, so this is the way I think and how I try and design things. Extensibility, I tried to kind of segment logic into files for each fragment and wrapper. So if you wanted to change something in one, you just have to change one file. I think that also makes it easy on developer experience. Although this directory is subject to change as well. So, and lightweight. I don't really take any dependencies at the moment. Yeah, I think. And these are just dev dependencies for testing. And what else did I have? Yeah, just for testing. So this kind of says nothing because I haven't added all the functionality that something like Rust Miniscript has. But I do plan to make it extensible. I come from Microsoft, a world of programming. Well, not come from, but I've done a lot of that in the past. And I used to work on with a project called Identity Server. And they were very extensible. And I like their design model for everything they did. And I'm trying to model my own code like that to put in as few dependencies as possible and allow people to inject whatever they want for things like key validation and whatnot. So example of Miniscript.js, this is my own example of the code. Again, not too crazy, and I'll actually show a short demo if I'm not too crunched for time. I have like 4 minutes, I think. I'll end at 3. But yeah, I use a thresh, which requires one of these conditions to be met, and then I just kind of print out what this script should be in ASM or in the opcode logic. So other cool things to check out are Miniscript templates, which were in Rob's talk, and it's a way that they're trying to standardize how you can do things with Miniscript. And I think that will be very helpful going on. The whole community is looking at certain Miniscript expressions and trying to make it as safe as possible. And even across wallets, having them standardized might be a good thing. It's easier to import, export things. And so yeah, where to find me? That's pretty much my talk. And I'll show you just a short demo of what my Miniscript.js can do. Again, not much yet. This is just my Twitter. And yeah, so that is all for the slides. And I'll just kind of show you this example of how basic what I do is. So yeah, the second screen here. So I think I just have it here. Hopefully that, don't actually know what that is. I should just mirror, actually. But here, 1 second. I'm just going to end this while mirroring. I had some slide notes. That's the only reason why I had separate screens. But just to make sure everything was working correctly, I actually have all the examples from the SIPA site, from the specification of Miniscript. He had a whole bunch of these examples of Miniscript, a single key, one of 2 keys, blah, blah. And I actually run all these examples to make sure I can generate opcodes from them. So if I just do ts node, SIPA site examples, it will generate each one, depending on what Miniscript expression is passed in. It shows all these opcodes, and then I just kind of put the size. And it does do some type validation again. So if you put in incorrect arguments that have an incorrect type, then it will throw a little error and have this quick start. But that's all I wanted to show as a part of this presentation. So thanks everyone for listening, and I'll end so that Sanket can go on his great presentation. But yeah, thanks.